In the last lesson on our third tutorial, we got a sprite actually showing up on our PyBadge. And if you remember, the definition of a sprite is that it's one of those 16 by 16 pixel images that we can move around the screen. And we used an image bank like we did for the background to grab the image. And this time we used stage.sprite and we grabbed a particular image, so in this case the fifth one, and this was the location that we placed it at. We added it into our layers, and then we also rendered it over and over again inside this game loop. So 60 times a second the spaceship's going to be refreshed over and over again, where our background just gets painted to the screen once and sits there. So today what we're going to do in this lesson, number 4, is we're actually going to use the buttons on the PyBadge to move that image around. So if you remember, this was our little spaceship, but at the moment it can't be moved around, it just sits there, so we want to use the D-pad to actually move it around the screen. If you've taken computer engineering and you know what an AND gate is, it might be interesting if you go here and understand bitwise comparison, because that's what's going to be happening. If you haven't taken engineering, hopefully it'll still make sense to you. It just might need to accept what I'm doing. So here's a picture of the PyBadge, and it turns out that each one of these buttons is referred to by a binary number, and the binary number is an 8-bit number, and each one of the digits represents one of these buttons. So the digit in the ones column is actually the B button, and the digit in the twos column, if you know binary numbers, is the A button. And the 4 represents the fours column, so this digit here is actually referring to start. And it turns out that the button over here, the last digit, or the 128th column, is actually the left-hand button. So when you press on these buttons, the PyBadge actually returns a number, an 8-bit binary number, and in this case here, a 1 here and a 1 here in the 128ths and the ones column represents that you're actually touching this button, the left-hand button, and the B button at the same time. So you could have all zeros, just a single 1 in a particular column if one of the buttons is pressed, or you could have more than a single number. So it's going to be important, if you understand computer engineering and the AND operator, why we're doing this. So it turns out that UGame, you can actually get this number. So if I have a variable called keys, and I go to UGame and I get what the buttons are currently pressed, if I happen to be pressing the 128 and the B button, or sorry, the left-hand button and the B button at the same time, then I'll have a 1 in the 128ths column, and I will have a 1 over here. So this would be the number that gets returned. If I just press the A button, then this number would be returned. So this variable right here is a binary number that has 8 bits, 8 ones or zeros, and if it returns all zeros, that means no button is being pressed. If there is a single button being pressed, then there'll be a 1 in that column. If there's several buttons being pressed, everywhere there's a 1, that is the particular button being pressed. So that's what's going to happen in here, and we're going to put this in our gaming loop, so 60 times a second we can find out what buttons are being pressed on our PyBadge. We're then going to use an if statement and take this key that was just given to us, and we're going to AND it with, it turns out UGame has some constants. So this constant right here turns out to actually be this particular binary number. And if you understand binary numbers, what's going to happen is it's going to do an AND operation, and we would only end up, this would be true if the A button was being pressed. If you don't if you haven't taken computer engineering, just accept that this if statement will return, it will print A if the A button is being pressed. So this Boolean expression will be true if A is being pressed. This Boolean expression will be true if B is pressed, and so on. So we have these constants in UGame, KX, which stands for the A button, and KO, which stands for the B button. KStart is the start button, so that's this one over here. KSelect is the select button, and then left, right, up, and down. So K right, K left, K up, and K down. So we're going to use this if statement to figure out what button is being pressed, and we'll just print it to the screen. If it happens to be the D-pad, what I'm going to do if it's hitting the right button, so this one here, what I'm going to do is I'm going to run this command called move on my sprite ship. So ship.moved, and it takes two parameters. How much do you want to move in the X direction, and how much do you want to move in the Y direction? So because I want to move just over 1 pixel in the X direction, I take the ship's current X position and I just add 1 to it. The Y value I'm not changing, so it just stays the same. If I'm pressing the left button, I want it to actually move to the left-hand side, which means I want to subtract 1 number. So if I'm pressing this button, the ship will move over 1 pixel. If I'm pressing this button, the ship will move in the negative direction. Remember that X increases to the right, but Y actually increases down on the Pi badge. So if I am pressing the up arrow, I want my Y to actually decrease. That's what's happening here. And I just want X to stay the same. And if I'm pressing the down button, I want my Y to increase by 1, and the X will stay the same. So we're just going to take our code from last time, and I'm just going to add this code right in here. So that's the code that we just saw, and I'm going to save it in. And I'm going to replace it. And now when I go back to my Pi badge, it's going to restart. And now you'll notice when I press the left-hand button, my spaceship moves left. When I hit the right, it moves right, and it can go up and it can go down. Now there is a problem because it can actually go right off the screen. So we don't have any restrictions keeping it off the screen. We're going to have to code that ourselves. The other buttons, if I press like A over here, it will just print A to the screen, or B, or start and select, just to prove that it actually is working. So today we were able to actually get our spaceship moving around the screen. The next thing we have to do is actually constrain it from not going off of the screen on us.